All right, here we go on number 3. So hopefully you've watched the first two, or if not, you already understand the first two, then this should be, either way, should be good and ready to go for this, I think. Okay, this is hypothesis testing for means. We did proportions already in class before I left on Tuesday. So we'll go through an example with this, and then I'll give you an example to try. Okay, suppose Apple claims the average battery lifespan for their phones is 14 hours. Based on my own experience, I don't think that's true. I question this. So the question is, if I question it, how do I determine? Do I just take one phone? I have my one phone and it only lasted 12 hours, say. Is that enough evidence to say that they're wrong? And the answer is no, not quite. Because this says that the average battery life is 14 hours. So what I need to do is take a sample of phones and look at what the sample average is. And then compare that average. We're going to compare that to the 14 and see what that looks like. So here's how we write this. We say H0, this is like my court case. H0, the claim is that mu is equal to 14. Okay? That's what they claim is true. I think mu is less than 14 based on my own experiences. So this is called the null hypothesis. And this is called the alternative hypothesis. The alternative is what I want to see if this is true. Okay, and the null is the original claim. Okay, so hypothesis tests always have these two statements right here. So this is basically, here, how about we do this? H0 is the defendant is innocent. HA is the defendant is guilty. Okay, so that's kind of our parallel to the courts or to a trial. So I need to come up with evidence and see if I have evidence that supports this statement beyond a reasonable doubt or not. Okay, so here's my evidence. My evidence is I took a sample of 20 phones and found the average span is 13.4 hours with standard deviation 1.2 hours. Okay, so what we have here, change colors here. Easier said than done. Okay, I won't change colors then. There we go. Okay, so I've got a sample of 20 phones. So N is 20. The average lifespan of my sample is 13.4, and the standard deviation is 1.2. So just like what I did on the first video, I want to see, my goal basically, or the question I'm asking is, how likely is this to happen by chance? Because if it happens by chance, I don't have any evidence to say that the average is less than 14. If it didn't happen by chance, now I got evidence towards it. Oops. Okay, so let's go ahead and take a look and see what we do to show that. Okay, let's go back to blue here. And we'll go with that. Okay, so let's see if I can leave that all on there. Well, in order for me to look at this, I have to look at the sampling distribution. And this is my t-curve from video 2. And the mean, we're assuming it's 14, because that's what we're starting with way up here, right? And the standard deviation of all my samples is, I don't know the population, so this is 1.2 divided by the square root of 20, which is 1.2 divided by square root 20 is 0.268. And again, it's a t-curve because I'm using 1.2. I'm using s over the square root of n and not sigma over the square root of n. Okay. All right, let's make this a bit smaller so I can leave it all on the screen here. Okay, so the question now is, my sample is 13.4, which is over here somewhere. How likely is it that I got 13.4? Well, that's this area over here, right? So I'm going to find that area. Now, before I can find that area, I have to make sure that this is a normal curve, because if this isn't normal, then I can't calculate areas. So, is this normal? Oops, I dropped my pen, sorry. Well, what do we need to know for it to be normal? You thinking about that? What 3 conditions? Samples have to be random. Is n 20 less than 10% of the population? Of course. And the last thing is n bigger than or equal to 30? No. But the population is normal. Because we were assuming that the lifespan is normal. We talked about that on the earlier, or assumed that on the earlier videos. So we're good. So if the population is normal, we know this is normal. So now it comes down to figuring out, what is this area over here? Okay, well, we can do it 2 ways. We can look up the t-score. Instead of z, it's a t. It's 13.4 minus 14 over 1.2 divided by the square root of 20. And I can look that up and then look it up on the table. Now, we haven't done the table for the t-scores. We're just going to use our calculator, and I'll show you the table in class. But for our test, we're going to do a what's called a t-test on our calculator, and it's stat, and then test. And if you do that and you go down to t-test is number 2. And you're going to go push, make sure it says for input. You're going to put stat. Then it's going to say mu sub 0. Well, that's the same thing as h0. So I've got to put in, what was h0? That is 14. And then it says x bar. Get that out of the way. Oops. X bar is my sample, which is 13.4. Sx is the standard deviation of my sample. So I'm putting these in my calculator. And n is the sample size, is 20. And then the next one, it says mu, and there's a not equal to, mu 0, a mu less than mu 0, or a mu greater than mu 0. Well, look up here at this guy right here. Mu 0 is 14. So I'm looking at mu is less than 14. That's what HA is, and so that's the one I want to make sure I highlight. And then calculate. And let's see, I'm just going to keep on going down here. So once I calculate mu is less than 14 and push enter, what comes up? T equals negative 2.23. That's my z-score, only it's a t-score, so I'm 2 standard deviations below the mean. And the p-value is 0.019 or 1.9%. So what is that 1.9% exactly? That 1.9% is that area right there. Okay? So what does that mean in words? In words, that means the likelihood of getting an average of 13.4 or less is 1.9%. I should say less by chance. Is 1.9%. Is that likely to happen? Not likely, since 1.9% is less than 5%. Now sometimes we'll call this alpha. Okay, sometimes we want our cutoff to be 1%, sometimes 10%, but if it doesn't say it, just use 5%. So what's my conclusion now? If the likelihood is 1.9%, and so that's not likely to happen by chance, so therefore this is now evidence. So my conclusion is, since 1.9% is less than 5%, I have evidence that what? What do I have evidence for? What if I have compelling evidence in a trial? I say they're guilty, don't I? So I have evidence that mu is actually less than 14. Okay, these are the two parts you need to say. You need to tell me your cutoff. That's beyond a reasonable doubt. And so then what do you have evidence? What do you have evidence for? I have evidence for mu less than 14. Okay, so here's the whole thing right here. And so what are the things that you need to include on a problem like this? You have to include, well, actually, let me try something I haven't used before. What do you have to have? You have to have, well, that didn't work. Okay, so you have to have the null and alternative hypothesis. You have to have the criteria. Okay, I would like you to draw this picture because that helps you visualize and see what you're doing. And then report out, because you use your calculator for this, report out your final answer. Okay? So as long as you do those things, and one more, I want you to tell me what test you're doing. Tell me it's a t-test. Okay, that way I know the test you're using. And then the last thing is to have the final conclusion. So all this other stuff is just me talking about the problem and how to do it. But this is the minimum requirement for a problem like this. Okay, so let me set you up with one here, and then I'll give you do it. Try it first, and then I will. And then I will come back or then I'll show you how we'll walk through it together. Okay, so let's get a thickness here. Okay. Okay, so we're going to start fresh up here. Okay, oops. Guess it won't let me move up a little bit until I start writing. All right, so here's the problem. Okay. Um, Suppose weights of chips in a bag are approximately normally distributed. Okay. With mean equal to 5 ounces. Okay, so this is the what we're saying. The weights are normally distributed with a mean is 5 ounces. Okay, I question that because it seems like whenever I get a bag of chips, I open it, it's half full, and so there's no way it's going to be 5 ounces. I think it's less. Okay, now when I say suppose weights, we're going to say this is the company's claim. I should have said that earlier. Company's claim. There's an I in there. Okay, so I think it's less. So what am I going to do? Okay, actually, what are you going to do? What do we need to have to test this claim? Okay. Well, the company's saying the mean is 5. I think it's less. So I need to take a sample. So suppose I take a sample of 15 bags. And I get the average for my sample is 4.7 ounces. And the standard deviation is, let's say, 0.3 ounces. Okay, so what I want you to do is I want you to perform a test, a hypothesis test. Which one? To check this out. In other words, to see, do I have evidence to refute the company's claim? Okay, so it's up to you. So I want you to do this on your papers right now. And pause this and then try it out. You can, well, actually, I'll go back and I'll show you this. You can use this, but I don't want you to just copy it without thinking about it. I want you to try it, okay, and then go back, and then if you need to, you can go back and look at it. But try to do it, see if you can do it without looking back at it. Alrighty, let me walk through it and see how you did. Okay, so here's the claim. The company's claim is that the mean is 5. So H0, let me make this thicker. So the company's claim is that mu equals 5 ounces. I think it's less than 5. That's what we said. We think it's less. Okay, and there's other ways to do this. I mean, there's other options. We could think it's more than 5, or we could think it's different than 5, which we'll talk about in class on Tuesday. So this is what I'm trying to show. Now, what else would I need to have now? I need to check the conditions to see if my test is valid. So is it a random sample? Question mark. Does it say I just told you that I have a sample, so we have to make note that we're going to assume it's random. The second thing, n is 20, is certainly less than 10% of the population. And number 3, is n bigger than or equal to 30? And the answer is no, but the population is normal because it was given. Okay? So we're good on all of those. So it's okay to continue. So now, what am I trying to do? I'm really trying to see how extreme is my sample. So here's the normal curve that we're using. Mu is 5. Standard deviation is 0.3 over the square root of 15. Okay? And my sample is 4.7. So the question is, how likely is it for me to get 4.2? Oh no. My battery's going down. I gotta save it here. There we go. Usually when it says warning, it gives me about 10 seconds to plug it back in. So I'm sorry. So the question is, if we make the assumption that mu is 5, because we're assuming innocence, we're going to assume that's true, what's the likelihood that I get 4.7, not 4.2, or less? What's the probability of that happening? Well, how do we figure that out? We can find the t-score, which is just like the z-score, 0.3 over the square root of 15. And then again, I can look it up on the table, or I can use the p-value and do it on my calculator. By the way, this is a t-test, and I need to tell you what test I'm using. So I do that. So I'm going to go to my calculator and do stat test t-test. Mu 0 is 5. X bar is 4.7. Standard deviation is 0.3 divided by square root of 15. N is 15. And I want mu is less than mu sub 0 on my calculator. So if I calculate it, I get the p-value is 2.5 times, or e, 10 to the negative 10th. Yikes, which is tiny. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I move the decimal 10 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, 10, one more. There we go. So that's essentially 0, right? So the likelihood of this happening is not likely at all. In fact, 4.7, if I change it on my graph, is really way over here. Okay, if I draw it more to scale. So what does that tell us? Is it likely that I got 4.7 for my sample? And the answer is no. So we're going to say since 0 is less than 5%, because this is 0, I have strong evidence that the average weight of a bag of chips see, now I'm putting in context, is less than 5 ounces. Okay, so that includes everything, right? And every single hypothesis test has the same format. You've got the hypothesis, got the conditions, you've got the mechanics, and you've got the conclusion. So if we want to do it, make it 4 parts, you got the hypothesis, the conditions, the mechanics, and the conclusion. Okay, there you go. Do what you can on the homework, and we'll talk a little bit more in class about it. We're going to keep moving forward, but we'll certainly answer a few questions and have some practice in classes in addition to this. All right, we'll see you on Tuesday.